Hey everyone, welcome back to another video of the AI in your pocket, Unmasking the AI you already use everyday series. As mentioned in the previous video, we started the series with exploring how AI is integrated into your smartphone camera. In the first video of this series, I walk you through how the different AI features are built into your cameras and automatically apply every time you take a picture using your phone. These features are image denoising, deblurring, night mode, portrait mode, and scene recognitions. However, we only touch on these features at a high level. In this video, we'll explore how they actually work by following the journey of a single photo through the AI enhancement process. Let's use image denoising as our example to understand how AI transforms your photo. Before we start, let's take a moment to set the scene. At this help you understand the big picture, where you at, what you have learned, what you're about to learn today, and where we're heading next. So in our previous lessons, we pull back the curtain on the artificial intelligence you use every day without even realizing it. We discussed how AI is deeply integrated into your digital life, from search results to the very photos you take. We established that understanding these systems is not just for tech experts, but is crucial for your digital agencies, which is your ability to make informed choices in an AI-driven world. We ended the lesson with a preview of the secret AI toolkit in your smartphone camera, including features like image denoising, deblurring, night mode, portrait mode, and scene recognitions. Today, we're diving deep into the first of those camera features, image denoising. By the end of this lesson, you will understand what image noise really is and what causes it in your photos. You will also understand the 4-step AI process for removing noise. They are feature extractions, noise detections, noise removal, and image reconstructions. You also understand how AI use feature extractions with convolutional layers and filters to see and identify important patterns in an image. After these lessons, we'll explore the critical training process that makes AI so powerful. We'll unpack concepts like backpropagations, loss functions, and gradients to understand how an AI model actually learns to improve its predictions and get smarter over time. Let's also talk about why it's important that we learn what we're about to learn today. In the previous lesson, we established that understanding AI is key to your digital autonomy. Today, we move from the what to the how by focusing on a tangible process like image denoising. You're building the foundational knowledge needed to grasp more complex AI system. The concepts of feature extraction and convolutional layers you learn today are the fundamental building blocks not just for camera AI, but for many other AI systems that impact your life. This lesson serves as the perfect bridge, turning the abstract idea of AI in your pocket into a concrete process you can see and understand, which will prepare you for the deeper concepts of AI training in Lesson 2. But first, what exactly is image noise? It's like those unwanted static that interfere with the clarity of a photo, making it look grainy, speckled, or blurry. It's usually caused by random changes in brightness or colors that don't belong in the true image content. When you take a photo, your camera sensors convert light into electrical signals to create the image. However, limitations in the sensor or challenging conditions can introduce noise. In dim environments, fewer light particles or photons hit the sensor. This creates random fluctuations because the sensor struggles to gather enough light, leading to a grainy appearance. Cameras often use a setting called ISO to adjust how sensitive the sensor is to light. Higher ISO settings are used in low light situations to increase sensor sensitivity, but this amplifies both the weak light signal and random electrical fluctuations, resulting in the speckled appearance you see in night photos. Think of it like a volume knob, but instead of amplifying sound, it amplifies the electrical signal that represents light. The camera sensor has inherent random electrical fluctuations, even when no light hit it. These fluctuations come from thermal activities in the sensor, that is, electrons moving due to heat. The fluctuation also come from electronic interference from the camera circuitry. At low ISO settings, these fluctuations are tiny compared to the light signal. However, when you crank up the ISO setting to amplify weak light signals, you're also amplifying these random fluctuations by the exact same amount. Now, even when a perfect image is captured during transmissions, whether to a storage device, over the internet, or to another system, equipment issues or external factors can also introduce noise. This is because to save storage space, images are often compressed into JPEG format. Compression discards some data, which can introduce noise-like distortions, especially in areas with fine details or sharp transitions. When images are sent over a network with limited bandwidth during video streaming, the system may reduce image quality to maintain speed. This can also lead to noise-like artifacts. The amplified random fluctuations becomes visible as randomly varying pixel brightness, meaning some pixels get a random boost and appear brighter than they should, while others get randomly diminished and appear darker. This creates what looks like grain or speckles, which are pixels that are randomly lighter or darker than the true image content. Most modern smartphone cameras automatically apply denoising techniques when capturing photos, especially in challenging conditions like low light or high ISO setting. They rely on a combination of hardware and advanced software to process images in real time. Sophisticated AI models such as convolutional neural networks are often used to train the algorithm to recognize and remove noise patterns. These algorithms analyze the image for patterns, distinguishing between actual details such as edges or texture and random noise. It then suppresses the noise while preserving important feature. The whole process happens automatically and almost instantly as you take a photo without you even being aware of it. Now let's see how AIs tackle this challenge. Before we dive deep, let me give you a big picture of the 4-step process that AI use to denoise your photos. Step 1, feature extraction. Your AI becomes a detective, scanning your photo with intelligent filters like smart magnifying glasses to identify important patterns like edges, texture, and shapes while ignoring irrelevant details. Step 2, noise detections. During these steps, AI acts as a specialist, using trained neural networks to distinguish between genuine image features and different types of noise. Specific activation patterns light up when the AI recognizes noise characteristic, whether that's Gaussian noise, salt and pepper speckle, or other interference types. Step 3, noise removal. Now AI takes on another role as a precision surgeon, using learned ways and expanding receptive fields to carefully remove the identified noise. Through nonlinear transformations, it preserves all the important details while making context-aware decisions about what to keep and what to eliminate. Step 4, image reconstruction. Finally, AI becomes an artist using an encoder-decoder architecture with skip connections to rebuild your photo. It takes all those cleaned up features and rebuilding them into a complete noise-free photo that looks natural and sharp. The fundamental principle that ties all these steps together is the concept of convolution. But let's put a pin on that for now. I'll walk you through each of the 4 steps, and then we revisit the concept of convolution. Step 1 is actually the foundation that makes everything else possible. It's where the AI model learns to see patterns in images, where the magic of convolutional neural networks really happens, and where concepts like backpropagation and training come into play. Once you truly understand how feature extraction works, how filters learn, how convolution operates, why nonlinearity matters, you have the foundational knowledge to easily grasp the subsequent steps of this process in our next videos. So let's dive deep into feature extraction and really understand how AI learns the patterns that make everything else possible. Let's start with step 1, feature extraction. When AI processes your noisy image, it doesn't see what you see. Instead, it performs feature extraction, which is the fundamental process that helps it understand and simplify important parts of an image. Think of it like this. Instead of focusing on every single pixel, feature extraction helps the AI pick out important details like edges, textures, or shapes. An image is made up of millions of pixels, each with a color or brightness value. Looking at every pixel individually would be overwhelming and inefficient, so the algorithm looks for patterns that stand out. This extraction happens through convolutional layer, which, as mentioned earlier, is the core building blocks that help the network seize and understand images. Think of them as special tools that scan an image to pick out important details, like a detective looking for clues. These convolutional layers apply learnable filters, which are like small magnifying glasses that slide over the image to find specific patterns. Each filter is a small grid, like a 3 pixel by 3 pixel grid, with numbers called weights or parameters. These weights are learned during training and determine how the filter responds to specific patterns in the input image, such as edges, corners, or texture. Each weight in the filter grid is adjusted to optimize the CNN's ability to detect meaningful features for the task at hand, like denoising in this case. Congratulations! You have just taken your first steps into understanding how AI sees the world. Before we move on to the next lessons, let's recap what you have just mastered today. You now know image noise is the grainy or speckle look in photos that often caused by low light, high ISO setting, or image compressions. You also know that AI tackle noise in the 4-step process: feature extractions, noise detections, noise removal, and image reconstructions. You know that the foundational first step is feature extraction, where AI uses intelligent filters to find important patterns like edges or texture. You know that this process happened in a convolutional neural networks, or CNNs for short, where convolutional layers apply learnable filters to scan the image for these features. Let's also review how the concepts we learned today are connected to those we have learned in the previous lessons, as well as those that we are going to learn in the upcoming lessons. So in the first lesson, we talked about the importance of demystifying the AI you use daily. This lesson did exactly just that. We took one of the secret camera features, which is image denoising, and broke down the very first and most critical step in how it worked. So you moved from knowing that AI enhances your photos to understanding how it begins to process them. This foundational knowledge of feature extractions is essential because the principle of how a machine learns to identify patterns are universal in AI. It also prepares you for the next lessons, where we explore the training process that teaches this filter what to look for. So that's it for today. In our next lesson, we'll hit pause on the four-step denoising process to understand how the AI model learns in the first place, as this is a crucial concept to grasp before we introduce other concepts. So get ready to discover how AI is trained using datasets of noisy and clean images, what backpropagation is, and how it helps the AI learn from its mistakes, how AI calculates error using the loss functions, and what gradients are and how they guide the AI to get better at its jobs.